So now we're going to do question. Okay, so now we're going to do question 6. Say that in a sketch below we are given the graph of f of x and the graph of g of x, and this is the restriction from minus 180 to 180 degrees, and we're also given a point of intersection between both graphs. So 6.1 says that we must write down the value of a and d. So if you look, we're having f of x and the value of a, it's this one here. So any value that is before your trig ratio is called an amplitude. So a is an amplitude. So for us to find a, we're going to look at the amplitude of f, right? So if you take a look, this is the highest point of f, this is the lowest point of f, right? So to find this value of a, you're gonna say a is equals to the highest point of f, the value of y is what? It's 1, plus the lowest point of f, it's -1, but you're just gonna write 1 divide by 2 is equals to 2 over 2, it's equals to 1. So the reason why we're writing 1 instead of this negative, is because we want to identify the amplitude, the height between this point and this point. So we are adding both heights and dividing by 2. So hence the value of a is equals to 1, and it's not negative here, it's just positive. Now we want to find the value of d, which is this one here in our g of x. So if you take a look, so this is our g of x, this one here, and this g of x starts at 1 and ends at 180, right? What I need you to note is the normal graph of g of x. If you have y is equals to cos of x, for example, the graph will start here and it will move down and it will end here. So just let me just fix the graph. So it will start here. So the graph will start here and will end here. So what this means is it will end at 360, right? And the height here is 1. And then this point here would be your 270 degrees, and this would be your 180 degrees, and this would be your 90 degrees, right? So what I want you to look at is where the graph ends. The graph ends at 360, and the normal value of x when it's 360, sorry, the normal value of x is 360, right, where the graph ends. But according to this g of x, it ends at 180. So it means that the normal value of x was divided by 2. For us to find d, we say d of x is equals to the period of the graph. So the normal period is 360, but because this current period is 180, so which means now that the d value, we divided the normal period of 360 by 2 to get 180, which is the current period of this graph here. Hence I say d would be equals to 2. So now 6.2, they say determine the coordinates of d. So what you're going to look at is this coordinate of d here. For us to find this coordinate, because we can't really tell at which value of x this coordinate is at, but we can tell the value of y, since the value of a is in line with the value of d. So we know that the value of y of d is equals to 1 over 2. You just want the value of x of d, right? So for us to find it, since a is in line with d, and we see that here it's 45 degrees, but here x value is minus 30 degrees, right? Let's find the difference here, which should be the same or equal to this difference that exists here, right? Difference between this point and this point should be equal to the difference between this point and this point, right? So if you subtract 30 degrees, say 45 okay, so if you say 45 degrees minus 30 degrees, you'll get 15 degrees. So it means the difference between this point and this point is 15 degrees. So the same applies here, 15 degrees. So it means now that for us to find the value of D, let me clear this up. So for us to find the value of D, we need to add it from the 35, and the value of D comes here, right? So we need to say the x value of D is equal to, so the minus 135 degrees minus the 15 degrees, which is the difference, right? You're gonna get minus 150 degrees. So this concludes now that the coordinates of D would be minus 150 degrees and 1/2. So now we're going to go for 6.3. 6.3 says that determine the values of x for which 6.3.1 the graph of f decreases at this period of minus 180 to 180 degrees. So we're going to look at the graph of f. So let me clear this up. So if you take a look at the graph of f, which is this one here, right? We want to know where it's decreasing. So if you check the graph here, it's increasing. The graph of f is increasing, and then this point it's 0, and the graph here is decreasing, right? So this is where the graph is decreasing. So it decreases between these 2 points here. Between these 2 points, the graph is decreasing. So what are the values of x when it decreases? So if you check here, it's minus 90 degrees, so that's the value of x, and here it's 90 degrees. So this concludes now that the graph decreases at x lies between minus 90 degrees, which is this point here, which is this one here, and 90 degrees, which is this point here. So the graph decreases between these x values, which highlights this point of the graph. So this is your answer. So now 6.3.2 says that when you multiply the graph of f and you multiply the graph of g, and it gives you the solution of y, which is less than 0, meaning it's negative, right? So the sign is negative. We want to identify the value of x, but have a look at that in between 0 and minus 180 degrees. So it means now that we want to know the value of x when the value of y multiplied with another value of y gives you a negative. But we are asked to look at 0 degrees up to minus 180 degrees. So we're going to look at this side of the graph. We want to know 2 points. When you multiply them together, they give you a negative solution of y. So this is graph of f, and the graph of f here, it's positive. The y values are positive here. They are positive, positive, positive. Why am I saying they're positive? Because from the origin going up, the graphs, the y values are positive. So hence I say they are positive, 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 positive here. And then when you look at the graph of g, the y values here are positive, 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 and then here they are negative, 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 negative. So they're negative here, and then they are positive here, right? So now the question says that when you multiply the graph of f and g, it gives you a solution which is less than 0. Less than 0 meaning negative solution. So where can we multiply both graphs and they give us a negative solution? So if you multiply a positive multiplied by negative, it gives you a negative. So let's look at those situations where we have a positive and a negative. So take a look at this portion here. it's positive. This portion of the graph is positive. So if you were to multiply with this portion here, positive multiplied by a negative, it gives you a negative solution. So that's where this happens, right? When you multiply the graph of G and the graph of F, gives you a negative solution. Even here, if you take a look here, the positive will multiply this negative here, and it will give you a negative solution of Y. So what are the values of X when this happens? So the values of X, if you take a look, we are between minus 135 and minus 45. So between minus 135 and minus 45, the negative will multiply this positive, giving us a negative solution. This negative will multiply this positive to give us a negative solution. So we can conclude and say X, sorry, so you can conclude and say X must lie between this minus 35 and this 45 here. So between minus 135 degrees and minus 45 degrees, that is where this happens.